Welcome to the deep dive. Today, we're going to explore something I think you'll find pretty fascinating.
Yeah.
The world of Linux system tests.
Okay.
We've got this really dense script,
Right.
and it's packed with tests for like every part of a Linux system,
Hmm.
from the file system, memory management,
Oh, wow.
even down to those nitty-gritty system calls.
Yeah.
It seems like it's from the Linux Test Project, or
Okay.
LTP,
Hmm.
a massive quality control project for the Linux kernel.
Right.
I'm really curious to see how they make sure Linux is as rock solid as we all know it to be.
Well, it's not just about being like rock solid.
Okay.
It's about being reliable,
Right.
no matter what you throw at it.
Yeah.
This script tests the very, very core
Mm.
of the Linux kernel.
Okay.
It pushes it to the limits to find any potential weaknesses.
Yeah.
And you have to remember, Linux runs on everything,
Right.
from
Right.
tiny embedded systems
Yeah.
to those massive server farms.
Yeah, it's everywhere.
It needs to be dependable in any situation.
So let's jump right in.
Okay.
The first part of the script is all about file system tests.
Okay.
There are a ton of these.
Yeah.
Each one getting like progressively more demanding.
Oh, really?
For example, there's GF20,
Okay.
which tests large file input and output with
Yeah.
very specific block sizes and ranges.
Okay.
Sounds like they're really trying to overload the system here.
Yeah.
And then we have GF29,
Okay.
which tests something called sparse files.
Right.
I have to admit, I'm not totally clear on how those work.
So think of sparse files,
Okay.
like a giant notebook.
Okay.
And you only write on like a few pages.
Mhm.
You don't need to like buy a whole new notebook for that.
Yeah.
You just use what you need.
Yeah.
Sparse files work similarly.
Okay.
They only allocate disk space for the data that's actually there.
Right.
This is really common in virtual machines
Okay.
and disk images.
Mhm.
So testing these files is crucial because
Yeah.
the file system needs to handle them without wasting resources.
Right.
And that's where GF29 comes in.
Okay, that makes sense. So they're making sure that
Yeah.
the file system isn't wasting space
Yeah,
on those empty pages, so to speak.
exactly.
And then we have FS Racer.
Okay.
I'm a little stumped on what a race condition even is in this context.
Race conditions can be tricky.
Yeah.
They happen when
Yeah.
multiple processes are trying to access
Okay.
or modify the same file at the exact same time.
Oh, okay.
If the system isn't like careful, data can get corrupted.
Mm-hmm.
Imagine like
Yeah.
two people trying to write on the same page of a notebook at the same time.
Yeah, that'd be a mess.
It'd be a mess, right?
Right.
FS Racer is designed to like trigger these race conditions
Oh, okay.
on purpose.
On purpose.
to make sure the Linux file system can handle them gracefully and prevent data corruption.
Wow, preventing that digital notebook mess.
Yeah.
That's no easy task.
It's not easy.
It's clear that each of these tests is using all sorts of parameters.
Mm,
Block sizes, file sizes,
right.
different access patterns. They're really trying to cover all their bases.
They really are.
I'm starting to understand why Linux has this reputation for stability.
So think about it, right?
Yeah.
Linux powers everything
Right.
from like financial systems processing millions of transactions
Yeah.
to scientific simulations crunching massive data sets.
Wow.
Each of these use cases puts a very unique strain
Yeah.
on the file system.
Okay.
The testing needs to be this thorough
Mm.
to ensure stability across the board.
So these tests are like a testament to how the developers are anticipating every way that
Yeah.
we use our computers.
Exactly.
Okay, next up we have memory management.
All right.
Full disclosure, this is a topic that often makes my head spin.
Okay.
There are some really interesting test names here.
Hmm?
One that caught my eye was Mapstress 08.
Okay.
What exactly are they stress testing here?
So Mapstress 08 focuses on
Okay.
memory mapping.
Right.
It's a technique that lets programs treat a file
Mm-hmm.
as if it were like part of their memory.
Oh, wow.
Right. This is a game changer for performance,
Right.
especially for applications that are dealing with huge data sets,
Okay.
because it cuts out constantly copying data back and forth
Yeah.
between memory and disk.
Right, so it's much faster.
Much faster.
Okay.
So Mapstress 08 pushes the limits of memory mapping
Okay.
to make sure that the kernel can handle it without falling apart.
Right. So for like massive databases
Yeah.
or busy web servers, this is essential.
Absolutely.
It's almost like they're creating a virtual extension
Oh, exactly.
of the available memory.
That's a great way to put it.
And then we have Mearson's 05.
Okay.
It seems to be about making the most out of RAM.
Yeah.
Could you break that one down for me?
So K75 stands for kernel same-page merging.
Okay.
It's like a memory optimization wizard.
All right.
It scans memory
Mm-hmm.
for identical pages across different
Yeah.
processes
Oh, well.
and merges them into a single shared page.
Oh, that's interesting.
Think of it like deduplicating your files, but for RAM.
Right, right.
And this can save a ton of memory, especially in environments running tons of virtual machines,
Oh, okay.
like in cloud computing.
That's how they squeeze so many virtual machines onto a single server.
Exactly,
It
exactly.
all makes sense now.
It all comes together.
And speaking of things that make me a little nervous, just reading them, we have UM03.
Yeah.
Is that what I think it is?
I got UMO3 stands for out of memory.
Right.
So as the name suggests, this test is designed to push the system into that dreaded scenario
Oh, no.
where it runs out of available memory.
Okay.
Now, it might sound scary,
Yeah.
but it's essential for
Right.
ensuring the system doesn't just crash
Right.
when this happens.
Okay, so it's less about making sure the system never runs out of memory
Right.
and more about making sure it can
Exactly.
gracefully handle that situation when it happens.
Gracefully, that's the key.
Okay, that's a relief.
Yeah.
Now we're on to system calls.
Okay.
And wow,
Yeah.
there's a lot to unpack here.
There is.
I see familiar ones,
Mhm.
open, read, write, the building blocks
Right.
for how programs interact with the operating system.
Yeah.
And then there are some that make me raise an eyebrow,
Like what?
like perf event open 03 and
Right.
the ominous sounding dirty 0W.
Right.
Can you tell me more about why these are so important to test?
So system calls are the fundamental way
Okay.
that user programs talk to the kernel,
Okay.
the heart of the operating system.
Mm-hmm.
Every time an application needs to interact with the hardware
Yeah.
or system resources,
All right.
it makes a system call. So they're constantly happening behind the scenes,
Got it.
right?
Right.
And given how fundamental system calls are,
Yeah.
even a tiny flaw
Mm-hmm.
can cascade into major security vulnerabilities
Oh.
or system instability.
Right.
Right. So these tests are designed to make sure that those flaws are caught.
Okay, so Perfevnip and Open on 3.
Yeah.
Does this one have to do with making sure things run smoothly?
You're on the right track.
Okay.
Perfect Node 3 is all about testing the kernel's performance monitoring capabilities.
Okay.
It's like having a speedometer
Okay.
for your operating system,
Right.
allowing developers to identify any bottlenecks that might be slowing things down.
Okay.
Right. This is especially important for demanding environments.
Yeah.
Like high performance computing or web servers handling thousands of requests per second.
Right. Where every millisecond counts.
Exactly.
Okay, that makes sense.
Yeah.
Now, what about Dirty SOW?
So that name might make you chuckle.
Yeah, a little bit.
But dirty CWW actually refers to a serious Linux vulnerability
Oh.
that was discovered a few years ago.
Okay.
It allowed attackers to gain unauthorized root access to systems.
Oh, no.
So the fact that it's included in this script shows just how comprehensive these tests are.
Right.
They're not just about general functionality.
Mhm.
They also include checks for known vulnerabilities
Right.
to ensure they've been patched up.
That's good to hear.
It's good to know, right?
Yeah. Yeah.
That they're learning from past mistakes
Yeah.
and proactively trying to prevent them.
Yeah. That's reassuring.
It is.
I'm also seeing tests for very specific features.
Okay.
Like iring 02.
Right.
I know iring is relatively new.
It is.
So I'm curious what's being tested here.
So you're right. Iring is relatively new.
Okay.
It's a super efficient way for programs to perform input and output operations.
Okay.
Think of it as like a high-speed highway for data, making things much, much faster than traditional methods.
Yeah.
So the inclusion of iring 02 here
Yeah.
shows that this script isn't just about testing like the old stuff.
Yeah.
It's keeping pace with the cutting edge
Right.
of the Linux kernel
Yeah.
to ensure that the operating system stays ahead of the curve
Okay.
in terms of both performance and
Yeah.
functionality.
So this script is constantly evolving,
It is. It has to.
along with the Linux kernel itself.
Exactly.
Now we're moving into the section
Okay.
on asynchronous I/O.
All right.
Could you give me just a quick overview
Sure.
of why that's so important to test?
So asynchronous I/O is all about making programs more efficient,
Mm-hmm.
especially when it comes to dealing with data.
Okay.
Think of it like this.
Uh,
You put a pot of water on to boil,
Okay.
right? With traditional I/O, you just stand there and watch it.
Right. You just wait for it.
With asynchronous I/O, you can chop veggies, prep other ingredients. You can do other tasks while you wait for the water to boil.
Right. So you're not wasting time.
You're not wasting time.
Right.
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 Your program doesn't waste time just waiting around.
That's a great analogy.
Thank you.
I can definitely see how that would improve performance,
Yeah.
especially for things like web servers
Absolutely.
that need to handle lots of requests at the same time.
Exactly.
So let's break down a few of these tests.
Yeah.
We have test block 3, prepare, write one request at a time,
Okay.
and test block 6, prepare, write, read, verify one request at a time. Can you walk me through these and explain why they're important?
Absolutely. So what we see here
Yeah.
is the incredible level of detail in these tests.
Okay.
In test block 3.
Yeah.
The focus is on
Okay.
making sure that each write operation is executed correctly.
Okay.
There's like double checking
Okay.
that every single line you write in your notebook is legible.
Right.
But test block 6
Yeah.
takes things like a step further.
Okay.
It not only writes the data,
Right.
but it also reads the data back
Okay.
from the storage device to ensure it was written correctly.
Oh.
And then it even verifies the data
Wow.
to make sure that it matches
Okay.
what was originally written, right? So this meticulous
Yeah.
multi-step process
Yeah.
emphasizes data integrity
Right.
and reliability.
Yeah.
Two things that are absolutely paramount for any operating system,
Right.
especially for one like Linux,
Yeah.
which is, renowned for its stability.
So it's not enough
No.
to just write the data.
Yeah.
They want to be absolutely sure
They want to be sure.
that it was written correctly.
Absolutely.
That level of attention to detail is impressive.
It is.
Yeah.
It highlights how the developers are thinking about all the different ways that data can be used
Right.
and potentially corrupted.
Yeah.
It's like they're anticipating every possible scenario
Right.
to make sure that Linux can handle it gracefully.
Okay. That's it for part 1
Okay.
of our depth dive
Oh.
into Linux system tests.
Yeah.
We've covered a lot of ground here,
We have.
from the file system and memory management to
Yeah.
the intricacies of
Yeah.
system calls and
Yeah.
asynchronous I/O.
Exactly.
What's clear
Yeah.
is that testing a complex operating system like Linux
Mm-hmm.
requires a
Yeah.
comprehensive
Yes.
and meticulous
Very meticulous approach. Yeah.
This script gives us a glimpse
Right.
into the incredible amount of work that goes on behind the scenes
It does.
to ensure the reliability, the
Sure.
performance,
Yeah.
and the security
Features.
of the Linux kernel.
Very important.
When we come back, we'll delve into even more fascinating tests.
Sure.
So stay tuned.
Looking forward to it. It really is mind-blowing. That this script is just like the tip of the iceberg
Right.
when it comes to the Linux test project.
Yeah.
We're talking
Yeah.
thousands upon thousands of tests
Wow.
covering practically every nook and cranny of the Linux kernel.
It's almost overwhelming to think about.
It is.
Most of us,
Yeah.
myself included, we just
Right.
take it for granted that our operating systems just work.
Yeah.
We rarely stop to think about
Right.
the sheer amount of effort that goes into ensuring that's the case.
It's a lot of work.
Yeah, it really makes you appreciate
Mm.
the work of all those developers and testers.
And it's not just about like finding and fixing bugs.
Okay.
It's about ensuring that new features integrate seamlessly
Yeah.
and that the kernel keeps performing well
Right.
as hardware evolves and new technologies emerge.
So they really have to be
Yeah.
thinking ahead.
Way ahead.
Speaking of thinking ahead,
Yeah.
I'm noticing a bunch of tests
Aye.
related to permissions and file ownership.
Right.
Challenge 01, Challenge 02, Challenge 03.
Mm-hmm.
It seems like a recurring theme.
It is.
And I have to admit,
Yeah.
I've definitely run into those pesky permission-tied errors.
Oh, yeah, we all have.
Before. It's frustrating,
Right.
but I'm guessing there's a good reason
There is.
for all this security around file access.
Absolutely. Linux is designed from the ground up to be a multi-user system, which means it needs a robust way
Yeah.
to manage who has access to which files
Okay.
and what they can do with them.
Right. So it's like having different levels of security clearance
Yeah, think of it like
for
this.
different parts of the system.
Exactly.
I can imagine that gets even more complex when you factor in groups and different levels of access.
Exactly. You can have,
Yeah.
individual users,
Right.
groups of users,
Mm-hmm.
and even system processes
Wow.
all needing to interact with the same files. So these tests make sure that the system correctly enforces permissions,
Okay.
no matter how complicated things get.
So those permission errors, they're like a built-in bodyguard
They are.
for the system, making sure no one accidentally
Right.
messes with critical files or snoops around where they shouldn't.
Exactly.
Okay, moving on.
Okay.
We have a whole section on signals.
Yep.
Can you remind me
Sure.
what purpose those serve within the operating system?
So signals are the way that processes communicate with each other.
Okay.
Or receive notifications from the kernel.
Okay.
Think of them like little messages.
Right.
Or alerts that can trigger specific actions.
Mm.
They're used for everything from handling keyboard interrupts to shutting down runaway processes.
So it's starting to become clear to me how critical it is to test all these different communication mechanisms.
It's essential.
What kind of chaos could ensue if signals aren't handled properly?
If signals aren't working correctly,
Yeah.
it can lead to all sorts of problems.
Like what?
Like processes freezing,
Okay.
crashing, or even data corruption.
Wow.
It would be like trying to have a conversation where people
Yeah.
are like talking over each other
Right.
or not responding at all.
Yeah, that wouldn't be good.
No, not good.
So these tests make sure
Yeah.
that signals are delivered reliably and that processes respond as expected,
Exactly.
keeping the system stable even under
Yeah.
heavy signal traffic.
Traffic.
I see a lot of variations here, like killer 2, killer 3, killer 1, killer 2.
Right.
It seems like they're trying every possible way to send and receive signals.
They're trying everything.
That makes sense when you consider that Linux supports a whole range of signals, each with its own specific purpose.
Exactly. Some are used to gracefully shut down a process, while others interrupt it to force it to handle a specific event.
Right.
So the tests need to cover all these scenarios to make sure that signal handling system is truly robust and reliable.
What impresses me is that they're not just testing these things in isolation.
No, they're not.
They're also looking at how system calls interact with each other.
That's key, right?
Right, because in a real-world environment,
exactly,
these calls are happening all the time.
All the time.
In different combinations.
Yeah.
Sometimes even at the same time.
At the same time.
That seems like a recipe for disaster if
it can be.
Things aren't carefully designed.
You've hit on a crucial point.
Yeah.
Testing system calls.
Okay.
One by one is important.
Right.
But it's not enough.
Okay.
The real challenge is understanding how they behave when they're used together in different sequences.
Okay.
And potentially by multiple processes concurrently.
Wow.
This is where things can get really tricky.
Yeah.
Because unexpected interactions can lead to like subtle bugs that are incredibly hard to track down.
So how do they test these more complex scenarios where so many things are happening at once?
They use a combination of techniques.
Okay.
So stress testing bombards the system with a huge volume of system calls in different combinations to see if it can handle the load.
All right.
Fuzz testing intentionally introduces random or invalid inputs to try to make the system crash or behave unexpectedly. And concurrency testing runs multiple processes at the same time.
At the same time.
Each making different system calls to look for race conditions and other synchronization problems.
It's like they're trying to break the system on purpose.
They are.
But in a very...
But in a controlled way.
Controlled and systematic way.
Exactly.
To identify those weak points and fix them.
Exactly. Find them
before they cause problems in the real world.
In the real world, yeah.
And speaking of breaking things, there's a whole section here on sockets and network programming.
Yeah.
This feels particularly important.
It is.
In our hyper-connected world.
Absolutely. So sockets are the foundation of network communication in Linux.
Okay.
Allowing programs to talk to each other over networks.
Right.
Whether it's, a local network or the internet.
And given how much we rely on
Right.
networks these days, I'm guessing security is a major concern here.
Absolutely. Anytime you have network communication, you're opening up the system to potential security risks. So these tests are designed to make sure that socket implementation is as secure as possible.
Okay.
They're looking for vulnerabilities that attackers could exploit.
So what kinds of vulnerabilities are they trying to catch?
So they cover a wide range of potential attack vectors.
Okay.
Including buffer overflows.
Okay.
Where an attacker tries to send more data than a socket can handle to potentially hijack the system.
Oh, wow.
Denial of service attacks.
Okay.
Where an attacker tries to overload the system with requests to make it crash.
Right.
Or become under-responsive.
Right.
And protocol implementation flaws, where an attacker exploits weaknesses in the way specific network protocols are implemented to gain unauthorized access or disrupt communication.
It's like a constant game of cat and mouse between the security researchers and the attackers.
Exactly. Constantly trying to outsmart each other.
You could say that.
Yeah.
The threat landscape is always changing?
Always changing.
So developers need to stay ahead of the curve.
They do.
By proactively identifying and fixing vulnerabilities.
That's an ongoing process.
Well, it's good to know that so much effort is going into making Linux as secure as possible.
As secure as possible.
Now, let's shift gears a little bit.
Okay.
To another area
Right.
that's crucial for performance.
Okay.
Process management.
Right.
What exactly does that entail within the Linux kernel?
Process management is at the heart of any operating system.
Okay.
It's responsible for creating scheduling and managing the execution of processes.
Okay.
Which are essentially the programs and applications that run on your computer.
Yeah.
It's like the conductor of an orchestra.
All right.
Making sure that all the different instruments are playing in harmony.
I'm seeing a lot of tests related to forking, cloning, and managing process life cycles.
Right.
What are they trying to achieve with these tests?
So fork and clone are the system calls
that
are used to create new processes in Linux.
Okay.
Fork creates a near identical copy
of
the existing process, while clone offers more control over what resources are shared between the parent and child processes.
Interesting.
So these tests make sure that those system calls work correctly. That processes are created and terminated without any hiccups.
Right.
And that resources are managed efficiently.
I see a test here called fork procs in 91,000.
Okay.
That sounds a bit intense.
That one's a stress test for the process creation mechanism.
Okay.
It tries to create 1,000 processes.
1,000?
Very quickly.
Wow.
To see how the system handles the load.
I can imagine that could bring even a powerful computer to its knees.
It could.
If things weren't designed properly.
Exactly. Creating and managing thousands of processes puts an enormous strain on system resources.
Okay.
So this test identifies any bottlenecks or performance issues in the process management code.
So it makes sure that the kernel can gracefully handle a high volume of process creations and terminations.
That's right.
Which is essential for servers and other high-load environments.
High-load environments.
It's amazing to think that something as seemingly simple as starting a program involves so much behind-the-scenes work.
A lot of work.
To ensure it happens reliably.
It's a lot of work.
But it's not just about starting processes.
No, it's not.
It's
also about managing how they run.
Right. Okay.
So Linux uses a sophisticated scheduling algorithm to determine which process gets to use the CPU at any given time.
At any given time, wow.
And this algorithm needs to be fair, efficient, and responsive to make sure all processes get their turn.
Yeah.
And the system stays responsive to user input.
So it's like a traffic cop.
Yes, exactly.
Directing the flow of processes to
That's a great analogy.
Keep things moving smoothly.
That's exactly what it is.
So they're testing the scheduler as well.
They are.
What kinds of tests do they run?
So the tests cover all sorts of scheduling scenarios.
Okay.
Including testing different scheduling policies.
Like what?
like real-time scheduling and fair share scheduling.
Okay.
Testing the scheduler's ability to adjust to changing system loads and testing for fairness to make sure no single process can like hog the CPU.
Right.
They want to ensure the scheduler can handle any situation you throw at it.
It's like they're trying to simulate every possible way processes could be created, scheduled, and interact with each other. To make sure the system doesn't
fall apart.
Doesn't fall apart.
It's really impressive.
It is.
How much thought and effort goes into this?
A lot.
What's interesting to me is that all this complexity is completely hidden from the user.
And that's the beauty of a well-designed operating system.
Right.
It hides all the complexity and provides a simple and reliable interface for users and applications.
Right.
But behind that simplicity lies a vast and intricate world of code, data structures, and algorithms all working together to make the magic happen.
Wow.
It's like a well-oiled machine where all the gears are turning seamlessly behind the scenes.
Well, after this deep dive, I certainly have a newfound appreciation for all that hidden complexity.
It's amazing, isn't it?
It really is fascinating to see how much is happening beneath the surface.
Looking back at this script, I'm also noticing a lot of tests related to memory allocation and management tests, like Malloc 01, Map 02, Marrow Map 03.
Okay.
It seems like they are really putting the memory system through its paces.
So memory management is another critical piece of the puzzle for any operating system.
Okay.
It's especially important for Linux because it runs on such a diverse range of devices, from tiny embedded systems with limited memory to those massive servers we talked about.
Yeah, with terabytes of RAM.
With terabytes of RAM, exactly.
Yeah.
So these tests are all about making sure the kernel can handle memory allocation and management without breaking a sweat.
Okay.
No matter the scale.
So it's about making sure that the system doesn't freeze or behave erratically.
Right.
Even when memory resources are stretched thin.
Exactly. The tests cover a wide range of scenarios.
Okay.
They try to allocate huge chunks of memory, free and reallocate memory over and over again.
Over and over.
And even see how the system reacts.
Okay.
When it completely runs out of available memory.
Wow.
Right? They also test the virtual memory system, which allows processes to use more memory than is physically available by swapping data between RAM and the hard drive.
It's amazing to think about all the different ways memory can be used and potentially abused.
Right.
It makes you realize how robust the kernel needs to be.
It does.
To handle all these situations.
And it's not just about handling like normal usage.
Okay.
It's about protecting against malicious attacks.
Right.
There's a whole category of security vulnerabilities that exploit weaknesses in how memory is managed.
Right.
So these tests are a critical line of defense.
Right, because if an attacker can manipulate memory, they could potentially take control of the entire system.
The whole thing.
Now we're getting into some tests that I'm a little less familiar with.
Okay.
Things like ANIFI 01, FANIFI 02, EPOL-CRATE 019. What are these testing?
So those tests are related to some of the more advanced features of the Linux kernel.
All right.
So INIFI and FANOTIFI are mechanisms for keeping an eye on file system events.
Okay.
They allow programs to be notify when files are created, modified, deleted, or accessed.
So it's like having a security camera.
Yeah, it is.
For your file system, constantly watching
everything.
For any suspicious activity.
That's a great way to put it.
And then we have EPOL.
Yeah. EPOL is a way to efficiently monitor multiple file descriptors, like sockets or files. It's essential for high-performance networking applications that need to handle a large number of simultaneous connections.
I'm noticing a pattern here.
What's that?
It seems like a lot of these tests are focused on features used in server environments or high-performance applications.
That's a sharp observation.
Okay.
Well, while Linux is a general-purpose operating system, it's also widely used in servers.
Right.
and high-performance computing, where reliability, performance, and security are absolutely essential.
Yeah.
So it makes sense that a big chunk of the tests would target those areas.
Well, after this deep dive, I feel like I have a much better understanding of just how complex
it is complex
and thorough this process of testing an operating system like Linux really is.
It's a truly massive undertaking.
Yeah.
But it's absolutely critical.
Right.
For ensuring the stability, the reliability, and the security
is essential
of a system that powers so much of our modern world.
Yeah. It really is
It's a testament to the dedication and ingenuity of the developers who work tirelessly to make Linux the amazing operating system that it is.
So what does this all mean for you, the listener?
Good question.
Hopefully you've come away with a deeper appreciation for all the work that goes into making Linux.
Yeah.
The robust and dependable operating system that it is.
Absolutely.
It's not just about writing code.
Right.
It's about
testing it.
Rigorously testing that code.
In every way imaginable.
In every way imaginable to ensure that it works flawlessly.
Flawlessly.
No matter what.
No matter what.
As you continue to use and explore Linux, remember the hidden complexity. Working tirelessly behind the scenes to make sure everything just works.
It's pretty amazing.
Thanks for joining us on this deep dive.
Thanks, everyone.